In this experiment, you will be finding the speed of sound in air at various temperatures by listening for acoustic resonances in a copper tube that is receiving sound from a speaker.
You will be driving a speaker using a function generator. The speaker connects to a function generator using banana plugs and this set of binding posts, which act as an adapter between banana connectors and coaxial BNC connectors. BNC connections are nice because they are somewhat shielded from noise in the environment and they're more compact. If you look at the BNC connector on this binding post, you see there are actually two conductors. There's one wire in the middle and there's a connecting shell around the wire. When inserting a BNC plug, you need to first align the locking collar with the locking pin on the BNC jack. Once you've inserted the plug, rotate the collar clockwise until it locks into place on the pins. To remove the BNC plug, you should first push the collar in to disengage the locking pins, and then do everything in reverse.
Let's look at the function generator in more detail. You want to make a connection to the output of the function generator on the far right, not to the sink connector. That is a common error.
Let's turn this on, shall we? Now when it first boots up, it will show you a jumble of text. Just wait for that to go away, then you can use it. You've already seen the power button. You probably want to be using sine waves in this, so you want to make sure that the sine output is highlighted there. You'll mainly be setting amplitude and frequency. As long as you don't end up in some odd menu, these two buttons are the ones you will use to change amplitude and frequency. If you want to change a value, you can either type it in on the right here on the keypad, and then press one of the buttons on the top for units. Or you can use the arrow keys on here to select the digit you want to edit, and then turn the wheel to change that value. Now before you get any output, you also need to make sure you have the output button activated. Note that the amplitude displayed on the function generator assumes that your circuit has a certain impedance, and this condition is rarely met in this course. If you really want to know what the function generator is putting out, use the oscilloscope. You can use a BNC T to split the function generator signal between the speaker and the oscilloscope. There is much more to the function generator than what I've discussed. See the manual for more. For finding the resonances, you can rely on your own ears, or you can use this microphone connected to an oscilloscope. You need to turn on the microphone first using this switch. Please remember to turn it off. This experiment can get quite loud, so we have also supplied you with a choice of disposable earplugs or earmuffs if you are using the microphone. Note the connections on the microphone and the oscilloscope. The microphone has a 3.5mm mono plug, while the oscilloscope has a BNC connector. We've given you an adapter cable that has a 3.5mm jack on one end and a BNC plug on the other. So let's make that connection. Speaking of the oscilloscope, let's look at that more carefully. Here's the power button. While it boots up, let's look a little more closely at the controls. The scope has two inputs that take BNC connectors. Each input has a voltage scale knob, so you can change those independently. There's only one time scale knob though. Now that it's booted up, you see that there's a grid of boxes there. Each box on the graph represents the amount shown on the screen. You can also offset the signals in voltage and time using these knobs. here's a demonstration. There's channel 1. Now channel 2 does not seem to be there, so let's activate it by pressing the channel 2 menu. And that has appeared now, and then you can offset that using the appropriate knob. You can also turn off a channel by pressing the menu button when it is active. You may need to adjust the trigger level of the scope using this knob. The trigger level is the voltage at which the scope will start displaying a repeating signal. This arrow indicates the trigger voltage. The scope can be configured to trigger when the signal is rising or when it is falling for a chosen channel. You can change these settings in the trigger menu. As with the function generator, there are many more features to the oscilloscope than what I've demonstrated. I will leave you with one more tip though, the auto set button. Often you press it and the scope displays the signal perfectly. Sometimes it doesn't though, so you still need to know how to use the scope manually. As an example, let's play with the oscilloscope a little bit. Let's see how auto set deals with my singing. Not very well, that didn't detect it. I'm going to try doing this manually. You need to get some more sensitivity, I think, because the signal is a little too weak. There we go. That's a little better. Even more sensitive. Isn't that lovely singing?
At some point, you want to do this experiment not at room temperature. We have some supplies to that. On the right is an example of a dewar for holding ice water, liquid nitrogen, or dry ice in ethanol. You can use 3-finger clamps to hold the copper tube mostly immersed in cold liquid. The clamps should not be left in the liquids themselves. When you use a dewar, make sure there's a mesh inside to protect the dewar from a fallen tube. The inside of a dewar is made of glass, so it is quite delicate. Even with the mesh in there, you really want to make sure the tube does not fall in. When you want ice water, just ask the technician for it, and you will receive it in this bucket. Dry ice in ethanol requires at least 48 hours of advance warning, and you must use it the day that you get it. It comes in a dark blue storage dewar, and you will get a separate chunk of dry ice in a styrofoam box for supplementary cooling. You can break it into smaller chunks by holding it in the palm of your gloved hand or on the styrofoam lid and hammering it with moderate force. Dry ice in ethanol is a significant hazard, not only because of the extreme cold, but because carbon dioxide gas is poisonous. CO2 is deadly at concentrations as low as 10%, and this is easier to reach in the small room where you do this experiment. Take precautions against the cold, like using gloves and safety glasses, but also take precautions against carbon dioxide poisoning by pouring the ethanol and dry ice mixture in the main lab room, where there is more air and better ventilation. Don't hesitate to leave the small room if the carbon dioxide is bubbling out uncontrollably, or if you feel unwell. Report a suspected CO2 poisoning incident immediately. Symptoms of CO2 poisoning include rapid breathing, rapid heartbeat, fatigue, clumsiness, and emotional disturbance. Extreme cold can make objects unexpectedly hard and brittle, so handle cold objects with care. Liquid nitrogen is both a suffocation hazard and a cold hazard. As with the dry ice, transfer liquid nitrogen in the main lab room, and wear safety equipment while doing so. The first time you transfer the liquid nitrogen from the large dewar to your small experiment dewar with the mesh, you should do so under TA, instructor, or technician supervision. Symptoms of low oxygen intake include headache, dizziness, nausea, and fatigue. As with dry ice, if you feel unwell while using liquid nitrogen, leave the room immediately and report the problem. Extreme cold can make objects unexpectedly hard and brittle, so handle cold objects with care. When you are done with the ethanol bath or the liquid nitrogen, leave the dewar of cold stuff on the table just outside your small room. This is also where the technician will leave the dry ice and ice for you when you need it. You will be using hot water to do experiments above room temperature, and you will be using an immersion heater to heat the water. You will be using the heater inside a trash can because the heater is too large for the doers. Don't worry, the trash can has never stored garbage. The trash can will be full of water and on a cart before you start. I would not recommend moving the trash can. Its handles are not made to withstand the weight of that much water. The trash can will be hot when the water is hot. Beware. Warnings aside, you can set up this part of the experiment as you did before, except on the cart. The heater must be completely immersed at least up to this nut any time the heat is on. Do not leave the heater on unattended. The heater is capable of boiling the water, and don't let that happen. This is the thermocouple and the associated temperature readout box. It gives you temperature in degrees Celsius. It's quite simple, plug it in and it runs.